Hello people, today we're going to talk about converting quadratics in standard form into vertex form. And we'll go through some examples of these. So let's go ahead and jump into our first example. We have y equals x squared minus 8x plus 15, and we're going to try to convert this into vertex form. And remember, vertex form is y equals a times the quantity x minus h all squared. And then we have plus this little k at the end here. So if we really look at vertex form, notice how, if we kind of isolate it here, there is a binomial that's being squared. So we're going to have to set something up that's a perfect square. So we're going to need to use completing the square here. So in order to use completing the square, we want to have a leading coefficient of 1 like we do, and we're really going to focus on just this x squared minus 8x. So we're going to ignore the 15 for now. So if you're focusing on just these two terms, to complete the square, you have the a is 1, your b is negative 8. So to complete the square, you take half of your b and you square it. Remember, in completing the square, it's half the b and you square. That'll give you the perfect square. So in order to do that, half of 8 is 4 squared. You'd have to add 16 to make a perfect square. But we can't just add 16 because that's not part of the properties of equations. You have to do the same thing to both sides or do something that's going to cancel out. So you can either add 16 to both sides. I'm going to write it like this. I'm going to add 16, and I'm also going to subtract 16. They cancel each other out. It's like we did nothing at all. You added 16 and subtracted 16. So you've really done, in the total scheme, like in the net here, you've done nothing to this right side. But the reason why we're going to write it out like this is because if we focus on just these three terms, that is a perfect square, and we can write that as x minus 4 all squared. If we expand this out, we'll end up here. Then we can combine these together, and negative 16 plus 15, you end up with minus 1. And now, if you look, we're in vertex form. So this is our final form. You also could have, instead of subtracting 16, you could have added 16 to this side. So said y plus 16. But then your next step would be to subtract 16 from both sides. So it's going to end up here anyway. With the minus 16, you'll still end up down here. So that is our first example. Let's jump into our second. Our second is very similar, so maybe you want to try this one on your own, see if you can do it. We have y equals x squared plus 2x plus 5, and we want to convert from standard into vertex form. So let's go ahead and look at our first two terms. A is 1, that's perfect for completing the square. Our b is 2. So take half of your b, which is 1, and square it. So half of your b, which is 1, square it is 1. So I'm going to add 1. We can't just add 1. We need to also either subtract 1 so it cancels out, or you could add 1 over here and then you'll end up subtracting it over eventually. Now if you look at the first three terms, that's the whole purpose of completing the square. We end up with x plus 1, that quantity squared. If we expand this binomial here, being squared, we're going to end up with that trinomial. And then negative 1 plus 5, we should end up with plus 4. So here is our vertex form completely converted here. Alright, our next one. Here we have one with a leading coefficient that's not equal to 1, and we'll see what we can do. 2x squared minus 8x plus 9. So to complete the square, we really want that leading coefficient to be 1. Makes life really easy then, or a lot easier. So what I'm going to do here is I'm going to make that leading coefficient 1 by dividing everything by 2. 2x squared divided by 2 is x squared. 8x divided by 2 is minus 4x. 9 divided by 2, I'll just leave as 9 halves. Since I divided the whole right side by 2, I have to divide the left side by 2. So I'm just going to put it as y over 2. Now, on this left side we have that y over 2, And if we want to get it back to y, all we have to do is multiply both sides by 2, but we're going to wait to do that because first we want to make this, or we want to complete the square and make a perfect square here. So x squared minus 4x, if we're focusing on just those two terms, take half of your b and square it, so negative 2 squared. You're adding 4 to make the perfect square, and then you're also, I'm going to write minus 4 because you want to do essentially, you don't want to change the value of this side, but we're going to write it like this so then we can make a perfect square. So y over 2 is equal to, well, this whole trinomial there is going to be x minus half of your b, so x minus 2 all squared. And then negative 4 is like negative 8 halves plus 9 is plus 1 half. And then all we need to do is multiply everything by 2. So y is going to be equal to, so you're going to end up with 2 in front of this polynomial here. So 2 times the quantity, x minus 2 squared. But you also need to multiply this term by 2. 1/2 times 2 is 1. And there's our vertex form. So now our a is not going to be 1 in the final. And we should expect that because the a over here was 2 as well. Alright, so let's go ahead and do 2 more. These get a little bit harder. There are some fractions involved, but it's the same process. So now it's just about keeping track of everything. So let's look at our next one. Y equals x squared plus 6x plus 3 halves. And we want to convert this into vertex form. So we have a leading coefficient of 1. That's nice. So we're going to have x squared. Half of your b is 3. And 3 squared is 9. So we're going to add 9. We're also going to subtract the 9. So we've essentially added nothing in total here. We do this to make our perfect square here. X plus 3 squared. If we expanded that, we'd end up over here. And then we just need to simplify here. So negative 9 is like negative 18 halves. So negative 18 halves plus 3 halves. That's like negative 15 halves. So minus 15 halves. And right there is your vertex form. Alright, our last problem that we'll do of the day before you try some of these on your own. We have y equals 3x squared minus 21x plus 22. Alright, so the first thing you should notice, we want to make that leading coefficient 1, so I'm going to divide by 3. So y over 3, divide the left side by 3, then we'll divide every term on the right side by 3, is equal to, 3x divided by 3 is just x squared, negative 21x divided by 3 is minus 7x, and 22 divided by 3 does not go in evenly, so we'll leave it as 22/3. Alright, now we need to complete the square over here. And when we're completing the square, you might notice we have an odd number. All the ones we've done before actually were even. So with an odd one, you're going to take half of 7. So you have negative 7 halves. You're going to square it, which will give you a positive 49/4. So to make the perfect square, you're going to add 49/4. And you're also going to subtract the 49/4. So you've added and subtracted the same thing, which is not changing the value of this side at all. And we still have the 22/3. This right here, even though there's some messy fractions, this is a perfect square. X, and then you're going to have, well, minus, and it's half of your b. So x minus 7 halves, all squared. And we need to combine these two terms together. So you're going to want to get a common denominator of 12, meaning you have to do 49 times 3 up top, which gets you 147 over the 12. And it's negative. You have the negative here. And we're adding that with, you're going to multiply the top and bottom by 4 here. So that's 88 over 12. When you combine these two fractions together, you're going to end up with minus 59. And we have 12ths. So now we're really close. We just need it to be y equals. So to make it y equals, you're going to multiply by 3. So you're going to have 3 times the quantity x minus 7/2 squared. When you multiply this fraction by 3, you're going to cancel out with the bottom, and the bottom will become fourths. And there's your vertex form. Some messy fractions, but still in vertex form. Alright, so that's all we have for today. You can go ahead and practice some of these, and have a nice day.